All right, we're nearing the end of Unit 2 as we get to piecewise function. You're going to love piecewise functions. All it is just an aggregation of a bunch of different types of functions on one graph. The good thing about them is they sort of tell you the zone in which you're trying to look. So let's look at some examples of piecewise functions. Here's an example of what a piecewise function looks like. Notice it has three functions, right? It has this function, that function, and that function. If we look at those separately and try and figure out where they are, that looks like a linear function, y equals mx plus b, and it says for x less than -1. So here's x is 0, x is 1, here's x is -1. Everything to the left of that is x is less than -1. And so this is our linear function. You see it? If we look at this middle function, it's constant, right? Just -3. X is just -3. I'm sorry, y is just -3. So y is -1, -2, -3. Y is -3 all through there, right? And we notice that that's from -1 up to 2, but not including the 2. And look at where this says this function lives. This is just the domain of that function, right? It's where are we actually looking at that function? Same thing with this bottom one, a square root function. Oh, look over here. We just talked about different types of functions. That looks like a square root function. And it said this function lives in the x greater than 2 realm. X is 1, x is 2. Okay, that's where it starts. That's perfect. Everything to the right of 2. If we want to look at these functions and evaluate them, this question is asking us to evaluate the function for these given values of x, okay? If we want to evaluate them, we can do it one of two ways. We can look at the graph or we can look at the function. I'm going to erase my handiwork here. But if we want to evaluate this function, f of 3, remember we're looking at function notation, f of x. So what this is asking us is, if x is -3, what is y? Or what is f of x, right? Okay, so if x is -3, we can do this one of two ways. We can look at the graph. X is 0, x is -1, x is -2, x is -3. What's y? It's 2, right? That's one way we can do it. If we were not given the graph, which in many cases you won't be given the graph, you're going to have to go back to this up here. And so what we're going to do is we're going to say, first off, we're still using f of x, so this number -3 is still our x. We need to figure out where does that live? Which domain does that live in? The -3. Is -3 less than -1? Is -3 between -1 and 2? Or is -3 greater than 2? And I'd say the only place that it can live, and these will all only live in one place, would be less than -1. Since -3 is less than -1, I'm going to sub it into that function. So I would say -3 minus 1 equals 4. I'm sorry, I typed that in totally wrong here. It's -x minus 1. I'm so sorry. So I need -x minus 1. That's -3 minus 1. So that's +3 minus 1. That's 2. I'm sorry. The reason I realized I'd done that wrong is because those two numbers should match. We should get the same thing regardless of whether we look at the graph or whether we sub it into the function. Let's try another one. I apologize for that. F of -1. So if x is -1, then y is what? If x is -1, so I'm looking right here, x is -1. Notice that that is an open circle. You see that? That's an open circle, so it's not there. I come down here, there's a closed circle, and that closed circle is on the y value, y equals -3. Let's see if we can get that from our graph here. F of -1. -1 fits into this domain, right? It's not less than -1, but it is greater than or equal to -1. So it fits into that domain. So I need to sub it into this function. And what this says is for every x in that domain, y is just equal to -3. And notice that that does match with what I got down here. How about for f of 2? This is x equals 0, 1, 2. I've got a closed circle right there. That's great. And that's on the y value 0. That's not off the x-axis at all. So that would be if x equals 2, then y equals 0. Let's just check that out with our graphs again. 2 would fit into this domain, right? It is greater than or equal to 2. It's not less than 2. 2 is not less than 2. 2 is greater than or equal to 2. So I'm going to sub it into this function right here. So that means that I need to do the square root of 2 minus 2, which is the square root of 0, which if you type that in the calculator, it's just 0. Notice that that does match up. All right, last one, f of 6. Notice that goes way off the graph. We can't even figure out what it is. It's out here somewhere. I know it's probably over 2, right? It's somewhere out there. We need to figure out where the 6 will go. If x equals 6, 6 is also greater than or equal to 2. You can check, is 6 less than negative 1? No. Is 6 between negative 1 and 2? No, it's not. The only place that it will fit is greater than or equal to 2. So I need to sub a 6 in there. That would be square root of 6 minus 2, square root of 4, which is 2. And that looks like where this line is headed, right? It looks like it's headed right for that area, which is right on the 2. If that was clear as mud, we'll do another example here. So we want to evaluate this function for the given values of x. We don't have a graph this time. We only have x values, the domain that we're looking for, and the 3 functions. They can be as many functions as you need. They could be 5 functions. They could be 2 functions. The 2 examples that we've had so far, they both have 3 functions. So negative 3, where is that in the domain? Negative 3. Is negative 3 less than negative 2? Is it between negative 2 and 1? Or is it greater than 1? I'm looking at those, and the only one that makes sense is negative 3 is less than negative 2. And so I'm going to sub my negative 3 into that top function. Negative 3 plus 7, which is just 4. How about negative 2? This again is x equals negative 2, right? That's f of x. Where does negative 2 live in this domain? It fits right there. It is greater than or equal to negative 2. And so to find this, I need to do negative 2 squared. As always, when you evaluate, you need to put that item in parentheses, especially if you're taking it to a power. It's an easy way to mess up if you don't. And I get 4 again. How about f of 1? That means x is 1. 1 is greater than or equal to 1, right? 1 is not less than 1. It's only greater than or equal to 1. It's certainly not less than or equal to 2, negative 2. So 1 is greater than or equal to 1. That means y is 3. And finally, f of 4. That means x equals 4. And 4 also fits in this part of the domain. 4 is greater than or equal to 1. It's not between 1 and negative 2, and it's not less than negative 2. So since it lands in that domain, it's just equal to 3. If you ever have just a constant number, that is your answer. You don't have to do any sub it in. That is just your answer, right? We're not doing 3 times 4 or 3 plus 4 or anything like that. It's just flat out 3. So the last example, we've got a application here, using a piecewise function in an application. A salesperson makes a monthly salary of $3,000 along with 5% commission on sales over $2,000 for the month. So on the first $20,000, he's not making commission. But if he makes over $20,000, then he's going to get 5% commission on that, okay? Write a piecewise function, I of x. Your piecewise function is always going to have those swirly braces. Write a piecewise function to represent the salesperson's monthly income for x dollars. So let's just use, I've written here his sales for the month, let's just use X. Let's say he sells X dollars per month. If he sells over $20,000, he's still selling X dollars worth of stuff, right? Regardless of how much he sells, he's selling X dollars worth of stuff. But if he sells over $20,000, then the overage would be X minus $20,000. Let me explain that. So if he makes $35,000, he's not getting 5% on all $30,000. He's getting it on sales over $20,000. So sales over $20,000 would only be $15,000. That's where I got this X minus 20,000 from. That's how much he made over $20,000, right? Anytime we made over $20,000, we can subtract $20,000 to figure out how much we're going to get that actual 5% on. All right. If he sells anything up to $20,000, he's just going to make $3,000, right? He's making $3,000. So he's going to make $3,000 regardless, as long as X is not greater than $20,000. If he makes $20,000, if he makes $5,000, if he sells $5,000, if he sells $7,000, $10,000, $15,000, it doesn't matter how much he sells. If he doesn't go over $20,000, he's not getting commission. If he doesn't go over $20,000, he's not getting commission. He's only getting his $3,000 salary. All right, if he does go over $20,000, then he's going to get $3,000 plus 5% commission. So he's going to get, I should have left myself more space here. He's going to make $3,000 plus 5% of his overage. $3,000 plus 5% of his overage. And his overage we said is X minus 20,000. I've totally run out of space. I apologize. And I can scoot this over just to make it look a little better for you. So here's our piecewise function. He's going to make $3,000 for anything under 20K. Anything up to 20K even. If he makes $20,000, he's still only making $3,000. If he makes anything over $20,000, he's getting his initial $3,000, and then he's getting 5% of however much he made over $20,000. We can try some numbers out here. So let's say he made $7,000, right? Let's say he sold $7,000. At $7,000, is he going to get commission on that? He's not, because he didn't make over $20,000. $7,000 is in this range, and so he's only going to get a $3,000 paycheck. Let's pick a number where he does go over 20,000, right? So let's say he sold $45,000. Then what he's going to get is $3,000 plus, I'm using this formula, 5% times, how much did he make over $20,000 is the question. He made $25,000 over. And notice that does fit this, the X minus 20,000. We can just sub that into our calculator. 3,000 plus 0.05 times 25,000. And that gives me $4,250. $4,250. With all applications, we want to look at these and see, did these numbers make sense? He sold $7,000 and he got some amount of money. He sold $45,000 and he got a larger amount of money. I would say that these numbers do make sense for the problem at hand. So our answer, it says to write the piecewise function. This entire thing right there, that's our piecewise function.